These are the frequently asked questions for Algebra 2 for section 4.1, day 2, starting with number 35. Number 35 asks us to write a quadratic function to model each graph. And what we want to remember is our generic formula that uses h and k for our vertex form. And I noticed from the graph that my vertex is at the point 2, 5. So I'm going to go ahead and put that in for h and k. So y equals a, x minus 2 squared plus 5. And in order to find a, in order for that to be the only variable left in this equation, I'm going to have to figure out something to put in for x and y. And that's just any other point that's on the graph. And I notice this point right up here is on the graph at 4, 9. So that would be a good choice to use for my x and y. And the y coordinate there is a 9, and the x coordinate is a 4. And then what I need to do is follow the order of operations so I can solve for a. So 9 will equal a, 4 minus 2 is 2, 2 squared is 4. So this is really 9 equals 4a plus 5. And then, let me scoot this up just a little bit here, I will have to subtract 5 from both sides and divide by 4. And my a value actually comes up to 1. So now what I need to do is go back to this step right here where I already had my vertex in, and I just need to realize that if a is 1, that will be y equals 1 times x minus 2 squared plus 5, and I don't need that 1 in front, that would just be simplified out. So there is my equation for that quadratic. And then I can go up to number 37 and go through the same process here. Here I have my vertex at negative 4, 2. So I think about my formula, and I realize that negative 4 and 2 need to go in for h and k. So when I put the negative 4 in there, it will be x minus a negative 4, which is really x plus 4 squared plus 2. And then again, I look at it and realize, well, if I'm going to figure out what a is, then I need to have another coordinate in order to put that in for x and y, so that a will be the only variable remaining. And that's going to be my little point 0, negative 6 over here. So I'm going to put the negative 6 in for y, and then the 0 will go in for x. And then I'm just going to follow the order of operations until I can figure out what a is. So negative 6 equals a, and in parentheses here, 0 plus 4 is 4, and 4 squared is 16 plus 2. So negative 6 really equals 16a plus 2, just putting that coefficient in front instead of behind, so that things are more comfortable there. Then I would subtract 2 from both sides and divide by 16, and I would get an a value of negative 1/2. And again, that needs to be placed back here where I had my vertex already in the formula. So it will be y equals negative 1/2 times the quantity x plus 4 squared plus 2. Make sure you can see that negative out in front there. So that's the process that we use when we want to write these in the form of a quadratic, which is actually the vertex form. Just go ahead and use that process. Put in your h and your k for your vertex, and then come back and put your x and y in so that you can find a, and then you're just substituting. That's what we need to do for all of those steps. On the next page, we have a couple word problems here. Number 38 says, a gardener is putting a wire fence around the edge of his garden to keep animals from eating his plants. If he has 20 meters of fence, what's the largest rectangular area he can enclose? Sorry, I had to yawn there. What you need to realize here is you have a rectangle, and you only have 20 meters of fencing. So we're going to start with that. Now, beyond that, you know absolutely nothing. So what I'm going to do is say that my width here is x. And I need something using algebra to represent my length. So what I have is, I know that the whole thing has 20 meters of fencing in it. Right now, I have those two x's in there. So my other two sides, I would get those by taking 20 minus 2x. instead of, trying to figure out how to add this, I'm going to subtract to figure out what's missing. And then, in order to get each one of those, I would have to divide by 2. So each one of those sides will be 10 minus x. And if I'm going to figure out what a maximum is on this, I have to find the area. So the area is going to be x times 10 minus x, because when you find the area of a rectangle, you do length times width, and that will be 10x minus x squared. But I want to have this in standard form, so I need to move my x squared to the front position. All right, now that I have this written as a quadratic, I can see that this is definitely going to open down. And so this is going to have a maximum, and it'll be located right there. And that is at the vertex. So what I need to do is figure out where is that vertex. And that's going to be in standard form, x equals negative b over 2a, to figure out the x coordinate of that vertex. And remember, we're talking about this as if it's ax squared plus bx plus c. So when I say negative b, I'm really looking at the 10 in the problem that we have here. So that will be a negative 10 over 2 times. A is the leading coefficient, which is whatever's in front of the x squared, and that is a negative 1. So we have negative 10 divided by negative 2, which is going to give us 5. And then the second part of this is I have to figure out, well, if I put a 5 in here, into the formula, what will I get? So far I know that 5 meters is what's going to maximize this. And there's 2 ways to do it. You can put it back in the formula, or you can go up to the picture and you can say, okay, the other one will be 5 too, and it'll actually be a square. But let's go ahead and put this back into the formula. So it will be area equals negative 5 squared, and then we have plus 10 times 5. Well, following the order of operations, we'll have negative 25 plus 50, and that's going to give us an area of 25. So with 5 meters as each one of the sides, the area will be maximized at 25 square meters. And let me make sure here, I believe the question just wanted the area. What is the largest rectangular area that we can enclose? So all we needed to tell them was the 25 square meters there. And again, at this point of having the 5, since it is a word problem, you could go back and put it up there as well, and 10 minus 5 would be 5. 5 times 5 will give you 25. Either way, it's not going to make any difference. Then, number 39, well, I'm going to have to do some erasing here so I have some room, first of all. The nice thing about this one is that they give us the equation. It's not a nice equation, but they give it to us. The equation for the cost, pardon me, yawning again. The equation for the cost in dollars of producing computer chips is C equals 0.000015x squared minus 0.03x plus 35, where x is the number of chips produced. Find the number of chips that minimizes the cost. What is the cost for that number of chips? So let me get this work out of the way and get started on this one. I noticed that my A value is positive, so that means it is going to open up, and if I'm looking for that minimum value, I am looking for the vertex. So it will be x equals negative b over 2a, and this is in the form ax squared plus bx plus c. So negative of negative 0.03 divided by 2 times 0.000015. And something kind of cool happens there, because when you do the math with that, whether or not you do it with a calculator or by hand, you get 1,000 chips. So we have 1,000 chips, and if we want to figure out the cost for that chip, then we need to take that 1,000 and we need to plug it in to both of these positions, and we definitely use the calculator for that piece. So we would have 0.00015 times 1,000 squared minus 0.03 times 1,000 plus 35, and put that into your calculator and it comes out with $20. So find the number of chips that minimizes the cost. That was 1,000. And the cost for that number of chips, $20. So we have the pieces that we need for this one. Then, the next problem that I thought you might have a little trouble with is really the same as the gardener and the fence problem. That's number 48. So maybe if you watched the gardener and the fence, then you might not need this one, which would be great. But number 48 says, write a quadratic function to represent the area of all rectangles that have a perimeter of 36 feet. They want you to graph the function and describe the rectangle that has the largest area. So first thing we have to do is figure out how to represent this with a quadratic. And if this is 36, again, I don't know what the width is, I'll just use x for those. So then I start to think backwards. You know, to get the two sides that are still missing, I have to take 36 minus the 2x that I have already accounted for, and I have to divide that by 2. So that will give me 18 minus x for the other two dimensions. And then again, the area of a rectangle is going to be length times width, so 8 times x times 18 minus x. And I'm going to go ahead and multiply this and reverse it at the same time. So negative x squared plus 18x is what I get for my quadratic. Now they did want me to graph it, so what I'm going to need to do is use my little negative b over 2a to figure out where my vertex is. So x equals negative b over 2a will be negative 18 over 2 times negative 1, because again, we have ax squared plus bx plus c. That's going to come out to 9. And now what I have to do is either, again, put it back up into the drawing or put it back into the quadratic. I'm going to go ahead and put it into the quadratic. So negative 9 squared plus 18 times 9. And that's going to be negative 81 plus 162. So that comes out to 81 square feet. And I'll try and use my little Cartesian coordinate plane here since I wanted to graph this, but really I should probably just focus on first quadrant since this is a word problem here. You can't have a negative length for a side. So we're going to put 9 and 81 on there. So I think what I will do is go by units of 5 for each one of these. So I'm just marking the 10, 20, 30, 40, 50. And then go up by 10s for my y's. All right. So the vertex for this one is at 981. So right about there. And then what I might do is just put 0 into it, you know, to see that I do get 0, 0 with this. And then use a little symmetry on the opposite side of my line of symmetry here that would be through the vertex. And again, the vertex is about right there. So it would look something like that. And again, would only really be in the first quadrant. That's our realization here. This is real world. So the last piece is, once we have that little bugger graphed, they wanted to know graph the function and describe the rectangle that has the largest area. So the rectangle would be 9 by, and if you put your 9 back up in here, you get 18 minus 9, which is 9 feet. Right there. And the area, the maximized area would be 81 square feet. Should put my little squared symbol back up in there too, because that was area. So graphing that is not the most pleasant thing in the world, but we can definitely do that if we know the vertex and we just use a little symmetry. It's not difficult, just kind of issue numbers there. All right, then number 52 says find the equation of a parabola in vertex form, and they're giving me the vertex. So again, what I want to do is take my vertex form and place h and k in there. So this will be a x minus 1/4 squared minus 3/2. And then for my x and y, I'm going to place the 1 and the 3 in there to see what I get. So 3 equals a times 1 minus 1/4 squared minus 3/2. And 1 minus 1/4 is 3/4. I'm going to do this in little steps here so everybody can follow along with all the fractions that are involved here. And then 3/4 squared would be 3/4 times 3/4, and that's top times top, bottom times bottom, 9/16 minus 3/2. So then I need to add 3/2 to both sides. And 3 is the same thing as 6/2, so 6/2 plus 3/2 will give you 9/2 equals 9/16. And then what I would want to do is multiply both sides by 16/9. And then these will be gone. And I can do a little cross reducing over on this side. The 9s will reduce each other right out, and 2 will go into 16 8 times. 8 times 1 is 8, and 1 times 1 is 1. 8 divided by 1 is just 8. And then finally, take that 8 and put it back up into the equation that had your h and k values for the vertex already in there. So y equals 8 times x minus 1/4 squared minus 3/2. And that should do, oh, wait a second, there might be one more. Let me look at 53 with you. I'm just going to cut that off, but I think we'll look at number 53. Hopefully 53 doesn't take you real long, and you already know what you're doing here. It says we're going to graph this absolute value function and the quadratic on the same axis. So I have y equals negative x minus 2, absolute value of that, plus 1. And I think about y equals a, x minus h plus k. And that means that my vertex is going to be at 2, 1. And that, of course, is where my axis of symmetry will go. And if I go ahead and take a look at my slope there, a is negative 1, so down 1 and to the right 1. And then just use symmetry to go equal but opposite on the other side. That is the graph of the absolute value function. And then I'm supposed to graph y equals negative x minus 2 squared plus 1. Well, for this one, we want to graph the parent function of y equals negative x squared first, and then we just want to move it. So you have to remember you had your negative 2, 4, negative 1, 1, 0, 0, etc. But we're just going to make those negative because this is reflected over the x-axis. So really what I'm doing as I'm talking you through this is going back through this table and thinking about what our xy table would look like, and then just putting a negative in front of it. So negative 4, negative 1, 0, negative 1, negative 4. So a negative 2, 1, 2, 3, 4. And then we have negative 1, negative 1, and 0, 0, and symmetry equal but opposite on the other side. But now, what I'm not going to do is I'm not going to make this solid, because this is not my final graph. Remember, this is shape. Whenever we have that A involved in there, that's our shape. And then I need to move it. So for my final graph, I'm going to change colors here and go to blue. And I need to move this 2 to the right and up 1. So 2 to the right and up 1 puts my vertex at exactly the same spot. And then let me put a couple more of these on here using symmetry. That should do it so you can see what's going on with it. I don't need to be incredibly detailed there with that. And then it says determine how they're similar and how they are different. Similar, same vertex. And same axis of symmetry. And that is at x equals 2. So those are the two things that they have that are the same. And then different is pretty obviously the shape. So absolute value is a V shape. The quadratic is a parabola, kind of a U shape when we deal with parabolas. So again, we can see those similarities and differences when we graph those on the same axes. And that should take care of the second day of 4-1.